It says here that in an arithmetic sequence, the difference between two consecutive terms is always the same. This is a pretty good book, but that's a boring definition. I've got something better. Monkeys on a number line. In an arithmetic sequence, you start with the first term. That's the first monkey. Put the first monkey right there. Next term, next monkey. Hang the monkey on the number line right there. Third term, third monkey. And this is a trick in an arithmetic sequence. All these monkeys have to be equally spaced on the number line. So the next monkey, we know where that one goes. Step, step. There's another one. Take another step. You get another monkey. And all of our monkeys are nice and equally spaced out on the number line. So when you hear arithmetic sequence, I want you to think monkeys on a number line. See, isn't that a lot more fun? So we got monkeys on a number line. And we can use these monkeys on the number line to come up with a nice formula for the terms in an arithmetic sequence. So we'll call the first monkey A. And we'll say that the gap between each two consecutive monkeys, we'll call that D for difference. So the first term is just A. The next term, well, I take one step. That's A plus D. The next term, well, I've taken two steps. That's A plus 2D. Next term, take three steps. A plus 3D. And so on. So now here's the question, what's the nth term? So if I go out to the nth monkey, what number is that? Well, I start at my first monkey, which is just A. And how many steps do I take? Here's the trick. You take n minus 1 steps. You don't take n steps to get out to the nth monkey. Look on the board. We've got 6 monkeys, 5 steps. So to get out to the nth term, n minus 1 steps. And each step is a difference of D. And there you go. There's your nth term of the arithmetic sequence. And we got that just by thinking about monkeys on a number line. So good job, guys. Good job, good job, good job, good job, good job, good job. Oh, sorry about that. Let's do a couple problems with monkeys on the number line. Now our first problem comes off the state target round of 2009. And here's the problem. We have two arithmetic sequences. Arithmetic sequence A starts at 30 and goes up by 10 each step. And then arithmetic sequence B starts at 30 also. And this one goes down 10 each step. And the question asks, what is the difference between the 51st term of A and the 51st term of B? Now we could break out our formula, figure out the 51st term of A, figure out the 51st term of B. We could do that. But it's a whole lot more fun to do this problem with monkeys. Alright, so here's what we're going to do. One monkey for each sequence. We got red for A, and we'll say that starts at 30. And, oh, B starts at 32, so these monkeys will just have to hang together. Now say we go forward a term in each sequence. Well, red goes up a step, blue goes down a step. One more step, when they each take one more step. Red goes up one more, blue goes down one more. So now we see the ends. First they were 2 steps apart, now they're 4 steps apart. One more step. Now one more monkey in each sequence. Red goes up a step, blue goes down a step. And now they're 6 steps apart. So each term, as we go out each term, our end monkeys get 2 more steps farther apart. So we started here, they started together, and they're 2 steps apart, 4 steps apart, 6 steps apart. We want to go all the way out to the 51st term. But we know how to get out to the 51st term. We have to take 50 steps. So we have to go 50 steps this way to the end red monkey, 50 steps that way to the end blue monkey. So the two ends will be 100 steps apart. And we know how far apart each of these steps are. Each step is 10. You take 100 steps, each is length 10, they're going to be 1,000 apart. And the answer is 1,000. We don't even have to write any equations at all. We just look at the monkeys. All right, next problem. Nice job, monkeys. So this one comes off the sprint round, state sprint round 2009. I think it was problem number 22. And again, we have two arithmetic sequences. The first one goes 2, 5, 8, 11. Just keeps on going by threes. And the other one goes 3, 10, 17, 24. And that one just keeps going by sevens. And the question asks for the largest number in both sequences that is less than 500, with the largest number that appears in both of them. Now, when we look at this at first, there aren't any numbers that are in both of them. So let's just continue the sequences a little and see if we can find numbers in common. If we continue the first one, bang, we hit it. We get to 17. Very nice number. So let's see. These two sequences are together at 17. Monkeys. It's monkey time. This is the red sequence, this is the blue sequence. And they are together at 17. So, you know what we do there? We put our monkeys together. Now, the red sequence is going up by threes. Going up by threes each step. So we'll have to throw up some more monkeys to show us the red sequence going up by threes. Go up by 3, up by 3, up by 3. I'll throw a few more up there. And there's our red sequence going up by threes. Now, the blue sequence goes up by sevens. So these are bigger steps than the red sequence was taking. So the red sequence was going up by threes. That's 3, that's 6. So 7's going to be a little bit more than that. It's going to be right here. And we're going to go up 7 more. Well, 3 will get you there. 3 will get you there. Get you to right there. Go up another 7, you'll be out here beyond the red monkeys. They don't seem to hit again. Let's throw a few more red monkeys up there. Oh, wait a second. It looks like this is going to end up right there. It looks like they're going to meet again right out here. And let's think about why that's happening. The blue sequence is going up by sevens, and I take 3 steps. That's 21. 3 times 7 is 21, so when I'm going up by threes, I'll take 7 steps. We'll go up by 21, and they'll be together again. So we know that this sequence is going to, these two sequences are going to keep meeting every 21. We're going to go up 21 from 17. We're going to get to 38. We're going to go up 21 from there. We're going to get to 59, and on and on and on and on. And we could keep listing until we get all the way up here. We can take a little bit of a shortcut. Again, we'll think about the monkeys here. We're taking jumps of 21. Well, what if we take 10 of these jumps? That's 210. So I can jump forward by 210 instead of just 21. Well, we can take 10 steps, so we can take 20 jumps. 20 times 21, that's 420. 420 added on to 17, that's 437. Now we're getting pretty close to 500. Now we can just add on 21s. 437 plus 21, 458. Add another 21, that's 479. You add another 21, you hit 500. 500, not less than 500. So the answer is 479 is the largest term that's in both sequences that is less than 500. So now the moral of the story here is, on these arithmetic sequence problems, we don't always have to just reach for our formulas and start bashing away. Instead, you should take a step back, get a look at the big picture, see the monkeys, and sometimes you'll see your way right to the correct answer. And when that happens, you'll feel pretty clever, but you should probably keep the bit about the monkeys to yourself.